first fight. Let's begin with first stage. Opponent, you may challenge reporter for one problem in 1 minute. Yeah, available problems are on the board.
We would like to challenge problem number 14, ruler trick.
Number 14 was challenged. Ruler tricks. Reporter, you got 1 minute to make decision. Problem accepted. Reporter, you got 5 minutes to prepare for your presentation. Write down the representative's name on the top of this.怎么样的？
他
Oops。刚刚不会啊，怎么现在忽然间？
对。
他设定的时间可能1-2个小时，所以现在他去找救兵了。
对，他去找电脑的主人。
哦。3秒钟。
电脑的主人在隔壁间。应该。
不好意思，这个电脑在保护阶段。荧幕，你看，它可以设定2个多小时，这样。现在要密码。 All right. Okay. Still fine. All right, before you may start your presentation.
So, hello everyone, my name is Huang Youjie from Taking Slate, and now I'm going to record the problem number 14, ruler trick. In problem statement, place a ruler on the edge of a table and throw the roll at its free end. The ruler will fall. However, if you cover a part of the ruler with a piece of paper and repeat the throw, the ruler will remain on the table while the ball will bounce off it. Explain this phenomenon and investigate the relevant parameter. And in my presentation, I will mainly focus on what is the main factor to call this phenomenon, and how do the force act on the ruler, and how do the relevant parameter affect the result. And the first part will be the observation. I'm going to tell you the main factor to call this phenomenon. And you can see we do the comparison of different area of covering paper. The one with a bigger area will make the ruler remain on the table, while the other one with a smaller area, it will let the ruler fall. And we can know that the area of the covering paper will affect the result. But with a different area, it will also have a different weight. So we need to do a more comparison of this. So the next comparison will be the different area, but with the same weight. So we signal the one which has a smaller area, and you can see they have the same weight now, but the smaller area will still fall, which means that the main force of the main source of the force is not the paper itself. And we can know that the paper area affects the result. So we can, and the one which have the most connection with the area would be the air pressure. So we can say that the main factor to call this phenomenon is the air pressure above the paper. And next is we do the observation left to the elevation under the ruler. And you can see when the elevation under the ruler, it will make the place which is under the paper. And when there will be the place under the paper, it will let the air flow around. When the air flow around into it, it will have a force to rise up the ruler and paper. And you can see that through the video, you can see that when with the elevation, it will be easier to fall. So we can say the air circulation will affect this phenomenon. And next, I'm going to talk about a theory about this. And now is the how do the force act on the ruler. And you can see the analyze of the ruler. And here in our picture, the direction of it is into paper. And here will be the analysis of the ruler. So first, I'm going to talk about the air circulation. You can see that the PT, which is the collision of air molecules, creates air pressure under the paper. And you can know that the PATM will be bigger than the PT. So the force of PATM will push downward and make the ruler remain on the table. And next, we use the W equals to F delta S and equals to the P delta V. And we can know that and get a total torque of air pressure, which L minus D divided by 2. We choose this part of the ruler and get a centroid and times the pressure on it and to get a torque. And the delta I is from the delta V divided by the delta S. And here is the torque equilibrium mechanical of ruler. And you can see that first, I'm going to talk about the left part of the ruler, which is on the table. And you can see that the L minus D divided by 2, just like mentioned, is this part of ruler centroid. And L minus D times the linear density will be the weight of the ruler. And we put a negative here because in this picture, the direction is into paper. And when we gesture, it will realize the force will act on the opposite weight of this. So we need to put a negative to correct this. And the next would be the part of the ruler which is outside of the table, and you can see that we use delta P divided by delta T to get a force. And there will be a critical condition of the limited height. And you can see L minus D, this part, the red part of here will be the pressure difference that caused by the pressure difference and have the force and on the ruler. And the blue part will be the air pressure above the paper and do the force as on the paper and make the ruler remain on the table. And it will be the solution of D. But in our experiments, we found out that the ruler will have a bending this phenomenon. So we need to consider the strain on it. And we use the Euler-Bernoulli beam theory to modify this. And you can see that we do the experiment and we to find the force and elevations relationship, and to get a result is our modulus of the elasticity will be the 0.36. So here will be a modification of critical conviction. And we put it here, and we can get a solution of D. We use a Python to calculate. Because it's too complicated, so after this we will use the one which is not modified, because in our experiment the modulus of elasticity won't affect too much, but we just want to find a connection with it. So we won't use this solution of D. Now I'm going to talk about the experiment setup and how do we release the ball at the location of a ruler we want. So first, I'm going to talk about camera. We will put it beside our experiment setup. And here we will put a lever to see if the camera is horizontal or not, which I think is really important. And here is the tool we release the ball. And how do we land the ball in the place we want? We will hang the rope and on the tools on the tools. And then to see the hang a heavy object and to see if it lands the place we want when it falls vertically. And next is the experiment data. And now I'm going to tell you how do the relevance parameter affect the results. So you can see that this will be the definition of our critical condition. And because when our experiment result is upon this line is unsuccessful condition, which ruler will fall. And when the data or the result is under the line, it will be the successful condition, which ruler will remain on the table. And here the first parameter is the size of paper. And you can see the size of paper increase, the effort arm still remains the same, so the resistance arm will increase, the limited releasing height will increase. But when it is in the same releasing height, you can see that the A increase, which is the air pressure above the paper. And the solution of D will also increase. You can see this. It's big with our experiment, so we can see the result is correct. And that is the elevation under the paper. With the elevation on the paper, through our charts that we can know, the limited releasing heights will decrease. And then you can see our theoretical model of the solution of D. When the delta A, which is the pressure difference to the force from the teacher different as on the ruler, increase, the solution of D will decrease. And through this step, when we have a set releasing height, it will fit with our result. And next is the distance of the hitting ball from the edge of the ruler. And you can see that the distance of hitting ball from the edge of the ruler increase, resistance arm remains the same, so the effort arm will decrease, and the limited releasing height will increase also. Then see our theoretical model of the solution of D. You can see that when the K increase, the D will also increase, and you can through our chart to see that the theoretical is fixed with our experiments. And that is a comparison of different balls. And you can see the one which have the bigger weights than the one which has smaller weights. You can see this one will fall and this one will remain on the table. And here, the weights of ball decrease, the resistance arm will remain the same, so effort arm will decrease, so the limited releasing height will increase. And this part of it, the delta A and the delta P will also be changed. But here, actually the video is a little bit unclear, but I can show you that this air column on the ruler will be bigger than this one. So we can know that the delta A, which will affect more than the delta P. So we can say that the delta P increase, even though the delta A increase, the solution of D will also decrease, will still decrease. So we can know that it also fits with our experiment result. And next will be the location of the ruler. And you can see that we place the ruler under the center of the paper and place the ruler under the edge of the paper is because our doesn't have a really clear image. But I can tell you that this one has smaller air column on the ruler. This one will have a bigger air column on the ruler. And we can know that the delta A will increase, so the solution of D will decrease, just like when you have a same reducing height. It can also fit with our experiment. So the distance of a ruler from the center of the paper decrease, the limited reducing height will increase. And next is the place of air circulation. And you can see, when holes on the paper, it will have made the ruler flow. And the one without the air holes on the paper, it will still remain the same. And now I'm going to do more investigation of it. And you can see the distance of the air circulation and ruler increase. The limited reducing height will increase. And you can see that the delta A, which because of the air circulation is and the ruler is closer, so the delta A will affect more than the one which is far away from the ruler. So delta A increase, the solution of D will decrease. And it also fits with our experiment data. And that would be the conclusion. Now I'm going to talk about the factor of the phenomenon. First, I'm going to tell you why this phenomenon can be established. Why it can be established because air pressure above the paper. And why this not can be established will make the ruler fall. It's because the air circulation under the paper. And now I'm going to talk about the relevant parameter. First, we use the torque equilibrium, which is we found out that every on decrease, the releasing height will increase. And other observation we do is when we put the elevation under the paper. So the delta A will increase, and it will make the releasing height decrease. And the ruler is closer to the center of paper, the limited releasing height will increase. And air circulation is closer to the ruler, the limited releasing height will decrease. Thank you for your attention.
All right, now question from opponent to reporter for 2 minutes.
Okay, thank you for the reports from the reporter. I would like to ask, what do you think is the main factor that caused the ruler to fall?
I think it's air pressure difference.
Okay, thank you. So how do you define your falling of the ruler? Because, never mind. In one situation, you can use ideal gas equation.
Like in a place that is like a place and won't have other air flow into it.
So does it fit your?
Just ideal situation.
Okay. I'm sorry. Okay. Do you control the contact area when you try different mass of the ball?
No, because I don't think that will affect you much.
Why?
Because we use a delta P here.
Okay. So what is your material of the paper?
Of the paper?
Yes.
It's just I just only know the band of it is a double AP.
Okay. And how about the material of your ruler?
A ruler is, one is a plastic.
Do you think, what do you think the material of the ruler will affect?
If its friction is bigger, then it might affect it.
So what's physical quantity for the material of the ruler affects?
I don't really understand your question.
Okay. What do you think the material of the paper will affect?
I think it's probably have the one which has more friction. It will not make a ruler may not make a ruler easier to fold.
Okay. How do you make sure that your paper will fit on the desk, on the table?
How do I?
How do you make sure that your paper will well fit the desk?
Because we will try the new paper.
Okay. 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 Thank you.
All right. Opponent, you got 3 minutes to prepare for your speech and discussion with reporter. the floor for up to 4 minutes and proceed to discussion with reporting.
Territories and battles competitors. I'm the opponent from Team or Forward. And today I will going to oppose problem number 14, ruler trick. This is a problem statement. Place a ruler on the edge of the table and throw the ball at its three ends. The ruler will fall. However, if you cover a part of the ruler with a piece of paper and repeat the throw, then the ruler will remain on the table, while the ball will bounce off it. Explain this phenomenon and investigate the relevant parameters. And the main focus of the reporter is how the air pressure affects. And this is a brief summary of the reporter. First, for the observation part, they talk about the paper area affects the results. And they talk about how the air pressure also affects it. And they talk about elevation, and they say that the elevation will make the ruler fall. And they also brought out the ideal gas equation, PV equals to nRT. And also they talk the torque equilibrium. And they also talk about the bending. And for the experiment method, they use metal with a hole to control the location. And for the data analyzed part, they try different elevation and different balls and the locations of the ruler at different area of paper. And for the conclusion part, they think that the air circulation, mass of the ball, placements of the ruler will all affect whether the ruler will fall or not. And these are the pros and cons of the reporter. For the pros, they have a clear comparison demonstration. And they also consider several variables, and they connected the theories with their results. But for the cons, they don't have a specific correlation between each quantities. I think they should do better if they can know whether the relation is linear or other kinds of relations. And they didn't quantify the results. They only only give us whether it is positively or negatively relations. And this will be the discussion that I would like to ask the reporter. First, for the theory, I will ask the PV. How do they use the ideal gas equation? Because I don't think that the environment that they do this experiment should fit the ideal gas situation. And next, for the experiment method, I would like to know that what is their definition of falling? Because in some situations, when they release the ball, the ruler will be hit off from the table immediately. But in some situations, the ruler will slide down from the edge of the table. So I would like to know that how do they define falling of the ruler? And also the material of paper and the rulers. It will affect some of the physical quantities, such as their bending angle and many other factors. And also the center of mass. I don't think they consider the torque that the center of mass can create. And also, what is the ways to test the pressure? And also for the data analyzed part, I would like to discuss the different area of the paper will affect. So I would like to invite the reporter for the.
All right, proceed to discussion.
Okay, so since you mentioned that the main factor that can cause the ruler to fall is the air pressure, so can you demonstrate how does the air pressure?
I say it's the air circulation, not air pressure. Air pressure is made the ruler remain on the table. Because the ruler, while the ruler flow, you will be the paper, right?
Yes.
You don't have an air circulation as long as air is in.
Okay, so do you think that the gap between the paper and the table is the main focus, right?
Yes.
So do you think that if the gap is bigger, the airflow can go inside will be larger?
Yes, you will.
So you try to make the air pressure underneath and on the paper more uniform.
Yes, yes.
Okay, so I agree with the reporter. The main factor that can cause the ruler to fail is to make the air pressure on and underneath the paper to be more uniform. Okay, so now let's talk about the folding. So since I mentioned that the folding, there may be different kinds of folding. So in your experiment, what kind of how do you define it?
Okay, so folding, just like you said, folding actually will have a different condition, right?
Yes.
The first folding would just like I used in our theoretical model, which
Yes.
is ideal one. And you will flow like this. Flow will just flow it and the ruler will just flow in this way. But if the flow like is some not really ideal, the ruler may be bounced and then the paper will. Okay, I have actually prepared one that I can show you. And you can see this kind of bounce, right?
Okay.
That's what you want to see, right?
Yes.
Yes. And this one is that we can really calculate and get a theoretical model because it's too difficult. It's because of the fluid and we can calculate. So we can have a theoretical model to prove this.
Okay. For this question, can we move to the board? For this question, I think the main focus to define the folding is at the center of mass. For example, if this is the edge and the ruler is on top of it, so if the center of mass can over the edge, I think we can define it as folding. What do you think?
But you mean the center of it? But in our experiment, we actually do different but even if the ruler is like here will be the center, right? And even if we put it like outside of the table, and when we put the paper here, it still will remain on the table. So it's not called folding. It's my opinion. Do you agree with me?
So do you think?
Yes.
Do you think in this situation you mentioned, do you think how does this paper affect this?
How the paper affect this is because and actually if we solve the paper, the air pressure will only do on the ruler, this part of the ruler, right? The part of the ruler which is on the desk, right? The air pressure will do on this.
Yes.
But with the paper around this, the paper will have a bigger area, which will make the torque of this go bigger, so it can make a ruler remain on the table.
Okay. Let's move on to the next question. Since you mentioned the ideal gas equation, can you explain again why you want to use it?
Because in our ideal theoretical model, we assume the ruler on the place of the ruler. Here's a ruler and here's a paper. We assume this is a vacuum here, so we can use a PV versus RT. But it's just an ideal theoretical model. So we can.
Okay. So what is the two main physical quantities you try to get from this EV equals to the number?
We just want to prove that the air pressure will be we want to prove that air like when it rises up, and this part of the air pressure was smaller than the ATM, right? The air pressure.
Okay.
Yes, and so the air pressure will gain to this. Have the air circulation gain to this way. We just want to prove this.
Okay. Thank you. Since that, okay, let's move on to the next topic. Since you talk about the torque, right?
Yes.
So in your experiment, you only consider the torque that the air pressure can create, and also
I also consider the gravity.
of the ruler.
Yeah, gravity. Two parts of the rule. I also consider the gravity. I have mentioned in my presentation.
Okay. So how do you test the air pressure?
Because air pressure is fluid that we can really calculate in we can quantify it, so we can calculate it really accurately.
Do you have a air pressure sensor or something?
Oh, we use it, but it can work. Do you have any suggestion of this?
I think the air pressure actually can work because for example, this is your ruler. I think you can try to place different parts of the ruler and get the average of the ruler, get the average of the
how the force act on this and get an average of it and get an air pressure.
Yes.
Okay, thank you. And I think I can maybe try it.
Okay. Do you think is there any way to know the air pressure? How does the air pressure?
Just like you mentioned, use the air pressure sensor. But when we are doing the experiments, we found out that the air pressure sensor cannot work in our experiments.
Okay, and I think you can also use the console to
Simulate.
Yes, and,
Okay.
and
But why if we don't have console, then how can we simulate?
okay. So I think this is what you can guess.
Okay.
Okay. Now let's talk about the thickness of your paper.
Okay.
You mentioned that you use the same mass and the different thickness.
Yes.
How did you did this?
Because this is a one with a smaller paper area, and this is one that with a bigger paper area, and we want to make it have the same width. So to make it have the same width, we need to stick this paper, and then they will have the same width.
So do you think that this tool will fit?
The thickness will change.
The thickness, yes.
The thickness is not a main factor to affect this.
Okay, but how do you make it different? I still didn't get it.
Okay, like using your paper, I just
Fold it.
it.
Okay, so you use stick like glue or something. Will
Yes.
it affect the mass?
Yeah, it will change the mass. So when we change the mass, then we will make a small one have the same weight with this. We just want to see.
Okay. Understood. But in different thickness, and you fold the level of you folding the paper might be different.
Yes, but in our experiments, we just want to use it to prove it. So, but in after you can see the experiment data we have. It doesn't say it on the paper. We just use it to prove that it's because of the air pressure. And
Okay.
can make you understand to be clear.
Okay. Can we move to the conclusion part?
Okay, sure.
You said that. Can you explain more about the relation of these observations?
Okay.
Yes.
Because you mean the elevation. Okay,
Yes.
so with the elevation, you can know that with the elevation, you will have a place under the paper, right? And you will let the air flow.
Yes. You only mentioned that the limited relation heights will be smaller, but what is the relation? Linear or quadratic or what?
Like because of the air will flow, you have a force to rise it up, rise the paper up. So when your limited releasing height is about effort arm, right? So in this time, the effort arm, like if you have an air circulation get into this, it will rise up the paper, and in this time, our effort arm, like it would, it is the same, and the one that without the air circulation, the one with the circulation will be easier to fold. So limited releasing height will decrease because it's about the delta P.
So do you have any formula to prove or
Yes,
what?
I have mentioned in my presentation here. You asked about what's observation? You mean elevation, right?
Yeah.
Yes, you can see it.
Okay, so do you have a clear relation about it?
Because the delta air will increase, so the solution of D will increase. You can look at this. The releasing height, when the releasing height is the same, and you can see that the one with the elevation, the D solution of D will decrease, right? Yes, it's because of the effort arm will decrease. Then
What I mean is like, is it a linear or what's relation between these two?
I think it's all about it's all about the torque.
Oh, torque. Okay. Okay. I think it's almost there. Thank you.
You all right? How long you must summarize the discussion in 1 minute?
We separated this discussion into few parts. And the first part we talk about the main factor that is air pressure. We both agree that if the air pressure under and on the paper become more uniform, then it can let the ruler fall out from the table. And for the next session, we discuss about how do they define the falling, because just like what I have mentioned, there are many kinds of falling in these experiments. So I think they should give a more detailed definition about it. And I think that the center of mass is something that they can talk more about this because just like what I mentioned, because in the experiment they said that if the center of mass is over the edge, it may also remain on the tables. So I think they can try to investigate more about how does the center of mass affects. And for the
Time's up. Excuse me. Question from reviewer to reporter and opponent. It's 3 minutes.
All right. So first of all, so I want to ask the reporter. So do you consider the friction when the ruler is falling?
When the ruler is falling.
Yeah, when the ruler is like getting hit by the ball.
No, because
So-
we're just saying it's an ideal situation.
All right. So what is it?
I think the friction should be considered because there might be some movements between the ruler and the ball that should release.
All right. So again for the reporter. So what does the speed of the airflow like affect the phenomenon? It would.
Yes, I think it depends on how does the ruler be removed.
Keep your answers short, please.
Okay. Right. Yes. So the third question for the reporter. So in the observation video. When the ruler doesn't fall. Okay. So when you do the experiment, will other than the ruler part, will it have other part that the air will flow in?
It might have.
It might have.
Yes, but it just we use the ideal situation to see the connection with it.
But in the graph,
Which graph?
so the theory, so with the data, yeah. So in your graph, like you didn't have a lot of error, but in the experiment data, it should have some error.
Error.
Yeah.
Okay, but we just want to see it's the modulus of elasticity, so I don't think it's really important.
All right. So what did you know?
I think the gap that the airflow can go inside may affect. So I think they should consider more.
So what does in your theory you mentioned that the Euler balloon theory? Yeah. So how exactly does it work in these effects?
Because when we have this elasticity of this, and the ruler will bounce back the ball, so it might affect the results. So we put A into our formula.
How do you?
I think I can agree with the reporters. Yes.
So how does the air pressure would affect on the when the ruler doesn't fall? Where does the air pressure work on?
Above the paper.
Above the paper. Does it have a specific spot? Are there any specific spot that the air pressure would work on?
I think just above the paper.
Generally. So what?
It can affect on the top of the paper, but it
Excuse
depends
me.
on whether.
Time's up. You got 2 minutes to prepare for your review. All right. Review. You may take the floor for maximum 4 minutes.
So this is the hello everyone. I'm the reviewer and team Fabric, and today I'll be reviewing your trick. So when it places a ruler on the edge of the table and throws the ball at its free end, a ruler will fall. And so the report they use the torque equilibrium and atmospheric pressure and critical condition, and he uses Bernoulli, Euler Bernoulli's Greek beam theory and the elevation and the air circulation to explain the theory. And the experiment part, her setup is she used a tool to release the ball and control the position of the camera. And the parameters are the paper size, the releasing height, distance of the hitting point from the table, and the weight of the ball, and the location of the ruler and the distance of the air circulation. So the results are when the effort arm decreased, the reading height decreased. So the strength of the reporter, I think she had a good qualitative phenomenon explanation, and she had a simple physics explanation, and she has some varied parameters, and she has some good setup. And suggestions, I think she lacks of considering the airflow into the space under the paper, and she uses dynamic fluid equation, which is PV equals nRT, to explain the phenomenon. And it's really weird because the paper doesn't have the air under the paper at the start, so it's pretty weird to use the period equals nRT. And she needs to define the rule of floating more clearly, and she needs to consider the friction effect and the speed of ruler flipping and the equation that is used in the theory. So the summary of the opponent. So he asked about the PV equals nRT and torque analysis, and his method is the method to measure pressure and how the air flow under paper, and the definition of the ruler folding. And the string he asked about some key questions, but I think he didn't answer the short question well, and he didn't understand the whole of the presentation, so I think he needs to work on it. So the opponent asked how to define the ruler folding, and the reporters say that just like in the videos, but I think that the reporters should define the ruler flip more clearly, because sometimes the ruler falls because of small friction, and the paper doesn't really flip entirely. And the opponent asked what is the material of the ruler and paper, and the reporter said he uses plastics for the ruler and friction and the paper that friction will affect. And I think that the material of the paper is important because the paper with strong structure would stick to the table. So I asked that, did you consider the friction effect of the ruler folding? And the reporter said that no, she only considered the ideal situation, and the opponent said that I think that the reporter should consider. And in some condition, the ruler will fall because the friction at support point is too small, but it doesn't overcome torque out of air pressure, which doesn't make it a flip. And I asked, do you think that this kind of ruler flipping will affect? And the reporter said that it might affect, and I think that the ruler flip passes, the flip on the paper would close to vacuum. And I asked, do you think the airflow around the paper will affect the pressure difference? The reporter said that she assumed there's only ideal condition, and the reporter said that the reporter should consider it, and the reverse being that the pressure difference caused by the airflow would cause some errors. And so about the Euler Bernoulli principle, it needs to be two free ends.
Excuse me.
So
Concluding remark from reporter for 2 minutes.
So here is my remark. So first of all, thanks for reviewer suggestion. And in our experiment, we did a different comparison of the area of covering paper to the different areas of the same weights. And through this, we can know that the manufacturing this phenomenon is the air pressure above paper. And now I'm going to talk about that. And we can see for the response of the opponent, we did quantify the result, which is limiting height, is in our presentation. In discussion part, the opponent and I discussed about the manufacturer to make the ruler fold down. And I think it's the air circulation around the experiment setup will affect it. And we talk about a different kind of folding. The opponent said the definition of the folding is because of the center of the ruler is outside of the table, which I think is not correct because because it's a paper and you will have air pressure, the force will make the ruler remain on the table. Even the center of the ruler is outside the table, it's still not folding. And we talk about the measurement of air pressure, and we didn't have the simulation and the, for example, like we can say the console. We didn't have it, so we can simulate it. And so we used to use the air pressure sensor to calculate air pressure. But I don't mind with our air pressure, we only have a zero data, so we can calculate it. And we just use the ideal theoretical model to prove it and have a connection with our experiment results. And we just only pad the paper together to prove the main factor to call this phenomenon. It's not paper itself. Instead, it's the air pressure affect this. And after that, in our experiments, the data we have, we didn't thicken the paper. We just only use only one paper and to do the experiment. And that's all my remarks. Thank you for your attention.
All right, thank you. Comes to the questions from jury members. Please take a stage.
So the review of sensor first and opposition and so it seems that the main factor that stop the ruler from falling is the pressure above the paper. Then I want to ask, is there any air pressure below the paper?
So in the ideal, in the ideal situation, the bottom of the paper would close to vacuum. So it creates a pressure difference. So there would create.
I think because there must be a gap between the ruler and the paper that is on top of it. So there might be a little bit air pressure, but I think it's very small. So.
The same with the reviewer. Yeah, you have it just like close to the vacuum.
Close?
Yes, because
In the ideal.
No pressure at all.
in an ideal situation.
In the ideal.
Okay. So again, I like to because both opponent and the reviewer challenge the problem. Okay, the air circulation, air flow, right? Yeah. Okay, under or above the paper. Yeah. But in the ideal case, if the paper doesn't move, okay, and the ruler doesn't fall, right? And is that important? The air circulation.
Yeah, because in the real world, so when they do the experiment, there may be some more airflow that flow into the under the paper, but the time is not enough for it to create fully load in the paper, so it doesn't fall.
What's your opinion?
I think that the main factor is that the amount of air underneath and on top of the ruler on the paper. I think it should be more balanced if they can make it.
You mean you say the air circulation?
If the paper doesn't move too much,
Oh,
the ruler doesn't fall.
actually, I do the experiment.
Yeah,
It's just put it and have an elevation, and you can see that with the elevation, it will have a place into the air flow around. So it will have a force to rise up the paper, so it will easier to fall.
Any other questions?
So the correction.
We'll move on to the next question.
All right.
All right, so question for the reporter. You mentioned about this parameter D, as you show here. You call this the releasing height? Is that the same?
No, it's not the same thing. The D here would be like, I have a real analysis of this. The D part is here.
Okay, so D is this the distance.
Yes, it's a distance that outside of the.
And that's what you call releasing height.
Oh, it's different. It's different. It's different. That's a theoretical model. We want to prove that our experiment is accurate, but it's different thing. It's just a.
So this D is different from that D. Here, the D.
Here would be the like a theoretical model that would prove our experiment is accurate. But here would be the result of this chart. Like you can see the trend here. When the size of paper increase, everyone will remain the same. So the limited release will increase. Just look at this trend. this is the change, and this would be we have the same releasing height, and the solution of the will change.
Let me follow the question again.
Okay.
In a calculation, you show the force is proportional to 1 over d squared, right? But in the experiment, the d to the initial releasing height goes straight. Could you elaborate how it's going to convert this to relation?
Connect these two parts of to connect these two.
From 1 over d squared to this linear relation.
I'm not sure if they can connect it really directly, but okay, I think we should just use more.
So you don't have any theoretical fitting on this data?
Fitting this data.
Theoretical fitting?
No, because we can compare.
Right.
So let me just finish
Yeah,
my question.
sure, yeah.
So this the D here is actually the resistance arm distance, right?
The D is the
Free
average.
end.
Okay. But then you have to imply that the releasing height is also increased. That's for different
Oh
points,
yes,
right?
because this blue dot will be the 25 times the 20
Okay.
times
The
25.
word is too small.
Oh, sorry.
It's kind of face down.
Yeah.
So in your equation, there is something called delta T or something?
Yeah, because we use because we want to reorganize the formula of the solution of it, so it will look quite complicated. Yes.
Right, so do you recall any phrase mention this delta T?
Delta T. Oh, sorry. Delta T here is the time that's the ball to touch the to have the time that the ball affects to hit the blue.
Right, so you have the measurement. You do the experiment, did you measure this delta T?
No, actually, because we can draw a vertical line.
All right, absolute story.
Can I see this for you? Right?
Okay. well,
Yeah,
yes, makes
so the
sense.
pressure, so the pressure under the paper will be like 1 atm. So for the correction from like, so it's more close to 1 atm. Yeah, 1 atm.
But 1 ADM on the top.
Slightly smaller than that under, so under the paper.
All right. Ready? All right, show score for the reporter. Start from me. 8, 7, 6, 8, and 8. Score for opponent. 8, 6, 5, 7, and 7. Score for reviewer. 7, 5, 6, 8, and 8. Thank you. So we're gonna cross the session. All right. Thank you all.
Thank you.